We are from RYS Academy faculty team, and today we'll learn course CBSE Class 10, Subject Mathematics, Chapter 4, Quadratic Equations, Topic, Quadratic Equations, Definition and Applications. For obtaining similar video explainers, please connect RYS Academy at 8910-890-311. Repeating the number again, 8910-890-311. Our another number is 8910-600-503. Repeating the number again, 8910-600-503.
Hey everyone and welcome. Go ahead and put on your detective hats because today we are jumping headfirst into an investigation. Our mission, to crack the case of quadratic equations. We're going to figure out what they are, how they pop up in the real world, and most importantly, how to spot them. All right, here's our investigation plan for today. We're going to start with the basics, defining our suspect. Then we'll learn how to translate real-world puzzles into math. We've got a tricky case file involving some marbles, and after that, we'll sharpen our skills at identifying these equations even when they're in disguise. And finally, we'll wrap it all up with the key clues you need to remember.
Okay, first things first, every good detective needs to know exactly what they're looking for. So let's get acquainted with our main suspect, what we call the standard form of a quadratic equation.
This right here, this is the classic police lineup. Any quadratic equation can be written in this form: ax squared plus bx plus c equals 0. That ax squared part is the quadratic term, and that little power of 2, that's its dead giveaway. Then you've got bx, the linear term, and c, which is just a constant. Now listen up, because this is the golden rule. It's absolutely crucial. That first number, a, the one in front of the x squared, can never, ever be 0. And why is that? Well, think about it. If a were 0, the x squared term would just disappear. And then it's not a quadratic anymore, it's just a simple linear equation. So no x squared, no quadratic. Simple as that.
So here are a few you might see out in the wild. And notice, they don't always show up looking perfect and tidy. The second and third ones here have their terms all mixed up, but they're still quadratic. Why? Because the highest power of x is still 2. All we have to do is just rearrange the pieces to see it clearly.
So now that we know what we're looking for, let's go out into the field. These equations are amazing tools for solving all kinds of real-world puzzles. So let's practice translating a situation from plain English into pure math.
All right, detectives, here's our first case file. We've got a toy factory, and their daily costs are a bit of a riddle. See, the cost to make one toy actually depends on how many toys they make in total that day, which we'll call X. We know the total cost for the day was 750 rupees. Our job is to build the equation that represents this whole situation.
Let's break down the clues one by one. First, the number of toys produced. That's our unknown, so we'll call it X. Simple enough. Second, the cost for each toy is 55 minus X. Okay, so the total cost for the whole day has to be the number of toys they made times the cost for each one. That gives us X times the quantity 55 minus X. And we know that grand total is 750. Now, when we multiply that out and rearrange the equation to get it into that standard form we talked about, boom, we get x squared minus 55x plus 750 equals 0. We've done it. We've successfully translated this word problem into a proper quadratic equation. If we were to solve this, it would tell us exactly how many toys they made.
Excellent work on that last one, but the cases keep coming in. So let's open up another case file and apply the same logic to crack this new puzzle.
Okay, here are the facts for this one. We've got two friends, John and Javanti. Between the two of them, they have 45 marbles. Then, a little tragedy strikes. They both lose 5 marbles each. Now, if you multiply the number of marbles John has left by the number Javanti has left, you get 124. The question is, how do we turn this story into math?
All right, let's follow the evidence trail. If we say John starts with X marbles, then Javanti has to have 45 minus X, right? Because they have 45 total. Now, after they each lose 5, John has X minus 5, and Javanti has, 45 minus X minus 5, which is 40 minus X. And our final clue is that the product of those two new amounts equals 124.
So after we multiply those terms out and clean everything up, we get this nice, neat quadratic equation.
x squared minus 45x plus 324 equals 0. Case closed, we've officially found the mathematical representation of the marble puzzle.
Okay, now for a skill that separates the rookie detectives from the pros. We need to learn how to spot a suspect that's in disguise. You see, not all equations that look quadratic actually are, and sometimes the ones that don't look it secretly are. This is going to take some careful investigation.
Here is the absolute #1 rule for this part of the job. You can't judge an equation by its cover. You have to simplify it completely, all the way down, before you can be sure of its real identity. Let me show you why this is so important.
Let's look at these two side by side. The one on the left, once you expand it and move things around, simplifies perfectly into our standard quadratic form. You can see the x squared term right there. It's a true quadratic. But now, look at the one on the right. It starts out looking like it's definitely going to be quadratic. But watch what happens when you simplify. The x squared terms on both sides completely cancel each other out, and we're just left with a simple linear equation. It's an imposter.
Okay, you're getting good at this. So, time for a real challenge. What about this one? At first glance, with that power of 3, it's basically shouting, "Hey, I'm a cubic equation." But is it? Could this be another case of mistaken identity? Let's dig a little deeper.
Okay, let's see what happens when we follow our golden rule and expand the left side. We get x cubed plus 6x squared and a bunch of other stuff. But, wait a minute. Do you see it? There's an x cubed term on the left side and an x cubed term on the right side. And what happens when we have the exact same thing on both sides? That's right, they cancel each other out.
And just like that, the disguise falls right off. After the x cubed terms vanished, look what we're left with. X squared plus 2x plus 2 equals 0. It was a quadratic equation all along. That is a fantastic piece of detective work.
Wow, we have cracked some seriously tricky cases today. So, before we close the file on this explainer, let's quickly review the crucial intel that every good math investigator needs to remember. So, here are your final takeaways. Number 1, always remember that standard form, and especially the golden rule. The highest power is 2, and A is never 0. Number 2, these aren't just abstract math problems. They are amazing tools for modeling real-world situations. And finally, maybe the most important takeaway of all, never ever judge an equation until you've simplified it completely.
This was an initiative from Roy's Academy faculty team, and today we've learned on course CBSE Class 10, Subject Mathematics, Chapter 4, Quadratic Equations. Topic: Quadratic Equations, Definition and Applications. For obtaining similar video explainers, please connect Roy's Academy at 8910-890-311. Repeating the number again, 8910-890-311. Our another number is 8910-600-503. Repeating the number again, 8910-600-503.